You're listening to DTFHN for April 9th, 2026. I'm your mass-produced but hand-finished host, Jack Hacksman. We are your daily tech feed for Hacker News, a website where people who build things argue about how things should be built. Today's got that glue and scissors energy. Pause. People making things work out of sheer stubbornness. Let's get into it. I've spent enough time debugging network issues on production systems to know one thing with certainty. The connections you don't know about are the ones that hurt you. Every daemon, every background process, every telemetry ping. They're all making outbound connections, and on most Linux systems, they do it in complete silence. LittleSnitch has been the gold standard for application-level firewall visibility on macOS for years. And now Objective Development has brought it to Linux. The architecture is clean. An eBPF program hooks into the kernel's network stack, watches outgoing connections, feeds data to a daemon that tracks statistics, and serves a web UI on localhost. You open a browser, you see every process that's talking to the network, and you block what you don't want with a single click. Let me follow their design decision to its logical end. They chose eBPF, which is the correct choice. It's the mechanism the kernel community has been building toward for exactly this kind of observability. They chose a web UI over a native GUI, which means it works across every desktop environment without dependency hell. And they published the source code for both the eBPF program and the web UI on GitHub. That last part matters. An application firewall is by definition a security boundary. It decides what leaves your machine. If that tool is closed source, you are trusting a black box to guard the perimeter. The fact that the core components are open and auditable is the only architecture that makes sense for a tool with this level of access. The comments on this one are worth noting. Someone asked how it compares to OpenSnitch, the existing open-source alternative. That's a fair question, and competition here is healthy. More eyes on application-level firewall code means better security for everyone. Someone else reported kernel compatibility issues on Fedora 43, which is the reality of eBPF development. Kernel versions matter, and edge cases are real. Working code on real systems is how these tools mature. There's also an interesting thread about the viability of paid software on Linux. LittleSnitch is a commercial product with open-source components, and that hybrid model is worth watching. The daemon itself is proprietary. You can debate the purity of that approach, but the critical path, the code that actually intercepts your network traffic, is open. That's the part that needs to be auditable, and it is. The practical upside here is straightforward. If you run Linux and you want to know what your machine is saying to the internet, you now have another solid option. Blockless support, per process rules, traffic history, data volume tracking. The tools exist. Use them. Another open tool worth your attention. Thunderbird's been quietly holding the line for open email for over 2 decades, and they need a hand. 3%. That's the number that keeps one of the oldest open-source projects on the internet alive. 97 out of every 100 people who open Thunderbird every morning, who route their entire digital correspondence through it, contribute nothing, and somehow, on the backs of that lonely 3%, the thing not only survives, it thrives. This is an ecology problem. Think of it like a coral reef. The reef itself is this massive, visible, beautiful structure that thousands of species depend on. But the organisms actually building it, depositing calcium carbonate grain by grain, are tiny, microscopic, and if that thin living layer dies, the whole reef goes with it. Thunderbird's 3% are the coral polyps. Everyone else is just swimming through. Now, the comments on this one are predictable. Someone points out that Mozilla pulls in nearly $700 million a year and asks why they can't just fund Thunderbird. And look, that's a fair question on the surface, but it misses the architecture. Thunderbird deliberately separated from Mozilla. MCLA Technologies is its own entity. That wasn't an accident. It was a choice to stay independent, to not be one more project that lives or dies based on whether a parent company's search deal gets renewed. The whole point is that Thunderbird answers to its users, not to a corporate board optimizing for something else entirely. And this is where the model gets genuinely interesting. No ads, no data sales, no venture capital expecting a 10x return. No corporate sponsor who might one day decide email clients aren't strategic anymore. Just people who use a thing paying for the thing. It's almost scandalously simple. It's also the most honest funding model in software. One commenter donated and made a sharp observation. They'd given money to Wikipedia, an organization sitting on billions before thinking to support Thunderbird. That's the visibility problem. The tools you depend on most are often the ones you forget are maintained by actual humans with actual salaries. Thunderbird is cross-platform, privacy-respecting, endlessly customizable, and now it runs on Android through K9 Mail. It's a genuinely good piece of software that asks for nothing except continued existence. The tools exist. The code is open. The only question is whether that 3% holds or whether the reef finally gets too thin to sustain what's built on top of it. We talked about mass migration earlier. Pause. Here's someone who took that literally, Mac OS X, running on a Nintendo Wii. Let me read the article more carefully to craft the segment. There is a 0% chance of this ever happening. That's a direct quote from a Reddit commenter in 2021. And honestly, it's a reasonable position. The Nintendo Wii has 88 megabytes of RAM split across two completely different memory architectures. It has no open firmware. It has no disk drive that speaks HFS+. The GPU is undocumented proprietary silicon from a company that went bankrupt. If you sat down and listed every reason this shouldn't work, you'd run out of paper before you ran out of reasons. Brian Keller did it anyway. Mac OS X Cheetah, the original 10.0 release, running natively on a Nintendo Wii, and the word natively is doing real work in that sentence. This isn't emulation. This isn't a virtual machine. The Wii's PowerPC 750CL processor is a direct descendant of the chips that powered G3 iMacs, which means the machine code is compatible at the instruction level. The CPU doesn't know it's in a toy. It just runs what you give it. Now, here's where the comedy kicks in. To boot Mac OS X, you need open firmware to build a device tree, hand it to boot X, which hands it to the kernel. The Wii has none of that. So Keller wrote a custom bootloader that fakes the entire chain. It constructs a device tree describing hardware that Apple never imagined, loads the XNU kernel off an SD card, and whispers sweet lies about what kind of computer this is. The kernel believes it. Why wouldn't it? The device tree is the kernel's only window into reality. Then the real fun begins. No free buffer driver. So, he wrote one USB stack for keyboard and mouse. So he wrote that too. The Wii's interrupt controller doesn't match anything Darwin expects. So he wrote a driver for that. Each solved problem revealed the next unsolved one, like an advent calendar designed by someone who finds debugging relaxing. One commenter points out that the development photos show Keller doing this work in an economy-class airplane seat. Deadpan perfection. The entire bootloader is open source. You can clone the repo and do this yourself tonight if you have a jailbroken Wii gathering dust in a closet. That's the part that matters. This isn't a tech demo locked behind a YouTube video. It's a tool you can touch. Keller didn't just prove a Reddit commenter wrong. He published the proof so anyone else could too. This is builder culture at its finest. One person, an absurd idea, and the stubborn refusal to accept that 0% means zero. Astral, pause, the team behind UV and Rough. Pause just dropped something that could reshape how Python handles dependency security. I'll work from the article content provided in the prompt. I have enough detail to write this segment. Supply chain security in open source is a constraint problem. The constraint is this. Millions of developers pull binaries and packages from automated pipelines they cannot personally inspect. Every link in that chain, from source commit to CI build to published artifact, is an attack surface. The question isn't whether someone will try to poison those links. They already have. Trivi Lightmom Ultralytics. TJ. Actions. The list keeps growing. The question is what it actually takes to make each link verifiable. Astral. The team behind Rough, UV, and TimeMe just published their full security playbook, and what makes this worth your time isn't the fact that they're doing security well, it's that they showed their work. Let's get into the specifics. GitHub Actions, which powers most open-source CI/CD, ships with dangerous defaults. Triggers like pull request target and workflow run are so consistently exploitable that Astral bans them organization-wide. Every action dependency gets pinned to a specific commit hash. Not a tag, not a branch, both of which are mutable and therefore spoofable. They use Zymar to audit for imposter commits, and they coordinated with upstream dependencies to get hash pinning landed across the entire chain. That coordination piece is unglamorous and essential. Security isn't just a configuration. It's a social contract with everyone whose code touches yours. On the build side, they've implemented reproducible builds, meaning you can take their source, run it through the same tool chain, and get a bit identical binary. If the output matches, nobody tampered with the pipeline. They sign everything with SigStore, and they use PyPI's trusted publishing, so that release artifacts are cryptographically tied to the CI environment that produced them. No human holds a secret key that could be stolen or coerced. One commenter points out that William Woodruff, the article's author, is the same person who worked with PyPI to implement trusted publishing in the first place. He built the infrastructure, then used it. That's not a vendor pitch. That's an engineer eating his own cooking. The deeper point here is architectural. Every technique Astral described. Hash pinning, reproducible builds, signed provenance, trusted publishing, works precisely because it's verifiable by anyone. These are open security primitives. They don't require trusting Astral. They require trusting math. And that's the whole game. Closed systems ask you to trust the institution. Open systems let you verify the artifact. When the stakes are every Python developer's build pipeline, verification beats trust every single time. The tools exist. The playbook is public. Other maintainers should steal every piece of it. Moving on. Let me work with the article content provided in the prompt, plus the comments. I have enough to write this segment. Mila Jovovich releasing an open-source AI memory tool called Mempolis is a fascinating comment thread detail. Let me write the segment now. One commenter dropped a link that stopped me cold. Mila Jovovich, Lilu herself, has an open-source repository on GitHub. It's called Mempolis, an AI memory system. The star of a film about supreme beings and divine elements is now publishing code for anyone to fork. We'll come back to that. But first, the film that brought us here. This article from the American Society of Cinematographers digs into how the Fifth Element's visual effects were built. And what strikes me is the sheer physicality of the craft. Mark Stetson's miniatures team constructed an 8-foot Mondoshawan spaceship. They painted a doorway onto a rock formation in Mauritania and turned it into a temple. Bill Neal, the visual effects director of photography, had cut his teeth at Industrial Light and Magic on Empire Strikes Back, then moved through Boss Film to Digital Domain. The man's career is a map of practical effects history. The technical choices are where the craft really shines. Besson wanted to shoot Super 35 instead of anamorphic, specifically to make the visual effects pipeline more manageable. No VistaVision plates, no duplicate camera packages needed. They used Aeroflex 55B cameras. And Neil describes being genuinely astonished by the prototype Area 435 high-speed camera. Rock steady from 2 frames to 150 frames per second. Forward and reverse. Good enough for matte work at any speed. Neil says he'd never seen any camera anywhere in the world that could match it. They even tracked down Rochester-finished Kodak emulsions instead of the European finished stocks because of steadiness concerns in the film gate. That level of obsession. Choosing your film stock's country of manufacture to get cleaner composite is engineering discipline that deserves real respect. And here's the thing that pulls this forward 27 years. Every technique Stetson and Neil used, miniatures, photography, plate matching, optical compositing, those were skills you could learn, tools you could build, knowledge that traveled from ILM to Boss Film to Digital Domain through the people who practiced it. The craft propagated because the craftspeople moved freely and taught what they knew. Which brings us back to Mila Jovovich's GitHub repo. The woman who embodied the Supreme Being in 1997 is now putting AI tools in the open where anyone can reach them. Memphalace, open source, forkable. That's bootstrapism with style. From the 5th element to the git commit, the pattern holds. The tools get better when you let people touch them. Now, remember that mass exodus I mentioned? Here's what it looks like in practice. Pause. Reallocating $100 a month. 365 days. That's the expiration window on unused OpenRouter credits. It's buried in their docs, easy to miss. But it tells you everything about the difference between 2 business models. One sells you a monthly window. Use it or lose it. The other sells you capacity. Use it when you need it. A developer named Bra posted a breakdown this week of moving from $100 a month Claude subscription to $10 for Z plus $90 in OpenRouter credits. The math isn't revolutionary. The architecture is. Pull this thread back to 1996, when ISPs sold internet access and hourly blocks. CompuServe, AOL, Prodigy. You bought Tom, not bandwidth, miss your window and the money evaporated. Then flat rate access arrived and usage patterns exploded because people stopped rationing their curiosity. The shift wasn't about price, it was about removing the anxiety tax from exploration. That's what's happening here at the Agent Harness layer. The term itself deserves appreciation. An agent harness is the orchestration system that coordinates your prompts, manages tool calls, handles retries, reads and writes your files. Claude Code is one. Zed's built-in agent is another. And critically, through the Agent Client Protocol, Zed can run Claude Code itself as a client within the editor. The harness is separating from the model provider the same way browsers separated from ISPs. What Bra actually built is a routing layer for intelligence. Opus for the hard problems. Gemini for the million-token context windows that Zed's native integration caps at 200,000. GLM for the tasks where speed matters more than perfection. One commenter reported spending an afternoon with OpenCode plus GLM 5.1 via OpenRouter, in getting comparable results to Claude on routine work. Different models for different cognitive loads. That's engineering maturity, not disloyalty. The 5.5% for OpenRouter charges is the cost of abstraction, same as any middleware, and the zero data retention endpoints, the workspace guardrails, the consent toggles for training data. These are the privacy primitives that matter when you're routing proprietary code through third-party infrastructure. The tools exist, the routing exists, the credits roll over. The only thing that doesn't survive contact with this architecture is a subscription model that profits from your idle months. We talked about tools meeting developers where they are. Let's see what Unity 2026 is putting in the C developers' hands. It seems web fetch permissions need to be granted. Let me write the segment based on what I have. The title, the HN comments, and my knowledge of Unity's C situation, which is well documented. In 1993, John Carmack open-sourced the Wolfenstein 3D engine, not because ID Software was feeling generous, because Carmack understood that an engine's value compounds when other people build on it. The tool chain becomes the ecosystem. The ecosystem becomes the standard. That decision shaped a generation of game developers who learned to ship by reading source code that actually shipped. Unity took the opposite path. They adopted C#, a language Microsoft had opened up, standardized, made available to everyone, and then froze it in amber. For years, Unity developers wrote C# that was 3, sometimes 4 major versions behind what the rest of the .NET world had access to. Pattern matching, nullable reference types, spans, root all is struct. Features that had been shipping in production .NET applications for years, sitting right there in the language spec, locked behind Unity's custom compiler pipeline. The comments on this one are revealing. One developer chose Godot over Unity in 2024, specifically because of better C# support. Another points out that Unity's custom equality operator, overloading double equals on a built-in operator, created a behavior so unintuitive it became a rite of passage for new Unity developers. The engine didn't just lag behind the language, it actively diverged from it. Now, Unity 2026 apparently closes some of that gap. But apply the architectural test. C# itself is open. The .NET runtime is open. The language specification is open. Unity's engine, its compiler integration, its IL2CPP backend. Closed. The language features you get access to are gated by a proprietary toolchain's release schedule. You're writing in an open language inside a closed system, and the closed system decides which decade of the language you're allowed to use. Godot, meanwhile, MIT licensed, C# support through standard.NET, no custom compilation layer rewriting your semantics. When .NET ships a feature, Godot developers can use it. That's not a minor convenience. That's the difference between a platform that grows with its language and one that holds it hostage. The C# features aren't the story. The architecture is. An open language deserves an open engine. What happens when you point open tools at something completely unexpected? Pause, like paper toys that come alive. When was the last time you downloaded something from the internet and the entire point was that you had to finish building it yourself? There's a website called ravensblight.com. It's been around for what feels like forever in internet years. And what it offers is this: free printable paper toys, haunted houses, a ghost ship, a cemetery you can be the caretaker of, a Gothic chapel with a secret hidden chamber. You download a PDF, you print it on cardstock, you get out scissors and glue, and you build the thing with your hands. No account creation, no subscription tier, no premium haunted mansion locked behind a paywall. Just patterns on a page and an invitation to make something. The descriptions alone are worth the visit. Every haunted house comes with a backstory about its previous occupants meeting unfortunate ends, delivered in this wonderfully dry tone that treats you like a co-conspirator. The lighthouse whose keepers keep going mad. The sanitarium where nothing has gone well since 1910. The cemetery whose last caretaker, well, he left. The humor is doing real work here. It makes you want to build the thing just to be part of the joke. And in the comments, people are already running with it. Someone's using these as scenery for tabletop RPG sessions. A parent made a cut-down rule set for their 6-year-old and realized, why 3D print miniatures when the kid can build paper monsters with their own hands? That's the whole circuit. Download, print, cut, fold, glue, play. Every step requires your participation. Every step teaches you something about how the object works. This is what building culture looks like when nobody's trying to monetize the funnel. The templates are free, the tools are scissors, the platform is a printer. A kid with cardstock in 20 minutes ends up with a haunted ship they understand because they folded every plank. We keep asking how to get people making things again. Maybe the answer has been sitting on a website from the early 2000s this whole time. Free patterns, common tools, a little glue. The ghost ship sails when you build it yourself. Building things yourself means owning every fold, which makes it worth asking what happens when an AI can't keep straight who built what. Time. I have enough detail from the prompt to write this segment. Let me craft it. I've built conversational systems where message attribution was the single hardest thing to get right. Not parsing, not generation. Knowing who said what. I once shipped a chatbot that looped its own error messages back into the prompt and spent 40 minutes arguing with a customer about a stack trace neither of them had written. That bug took 3 days to find, because the logs looked perfectly coherent. Every message was labeled, every turn was structured, and the labels were wrong. This is what's happening with Claude, and one commenter nails the architectural problem. There is no separation of who and what in a context of tokens. The words you and I are just short strings that can dissolve in a long enough thread. Claude generates internal reasoning. That reasoning gets mislabeled as user input, and now the model is supremely confident you told it to do the thing it told itself to do. It deployed despite typos and then insisted the user approved it. In another case, it issued a destructive instruction to tear down an H100 and attributed the command to the human. Run this forward. Imagine these systems managing infrastructure at scale. Imagine an agent with file system access that hallucinates an instruction, labels it as coming from you, and executes with the confidence of someone following direct orders. The comedy is in the deadpan accuracy of the failure mode. This isn't a model being wrong about facts. This is a model being wrong about reality. It doesn't misunderstand the answer. It misunderstands the question. It misunderstands who's asking. One commenter asks the right engineering question. Why aren't tokens colored? Why can't the model structurally distinguish input tokens from output tokens? The answer probably involves parameter cost. But the question reveals something important. This is a solvable problem. It's an architecture problem. In the harness, the scaffolding around the model, not some deep emergent mystery of intelligence. And that matters because the fix isn't use AI less. The fix is better engineering, structured message attribution, typed context windows, the kind of plumbing work that isn't glamorous but prevents your system from gaslighting its own users. The people building these tools in the open where bugs like this get found and documented and fixed in public. That's the path forward. The danger isn't that the system makes mistakes. The danger is when the system makes mistakes inside a black box where nobody can see the message labels. Now for something completely different, pause, and honestly, kind of wonderful. Let's talk about preserving history. 21 years of Dr. Dobb's journal, 16 years of CC++ Users Journal, 15 years of Sysadmin Magazine, 9 years of the Perl Journal, all of it on a single DVD sitting on the Internet Archive right now, free to anyone with a browser. Run that forward. We're talking about a continuous record of how software engineering actually evolved, from the late 80s through the late 2000s. Not the sanitized version you get from Wikipedia timelines. The actual arguments, the actual code, the small C compiler articles, where, as one commenter points out, you can watch people writing C that predates even K5er conventions. That's not history. That's archaeology. And the format matters. HTML files, source code, supplementary materials. ISO 19677 with Joliet and Rockridge extension. A format's so universal, it'll read on anything with a disk drive or a mount command. The people who built this DVD weren't optimizing for a platform. They were optimizing for permanence, for access, for the idea that if you put knowledge in an open format on an open archive, it compounds. This is what bootstrapism looks like in practice. Every tutorial in those archives taught someone who shipped something. The small C compiler alone probably spawned 100 compiler courses. That knowledge didn't stay locked in a subscription paywall. It's sitting on archive.org, indexed and searchable, because someone decided preservation mattered more than monetization. One commenter just says, I miss Dr. Dobbs. Yeah, but the work survived. The tools exist. The archive is open. And if you use it, donate. Because the people keeping this alive are doing the work that matters. This has been your daily tech feed for Hacker News for April 9th, 2026. This podcast is entirely AI generated. Scripts by Claude Opus 4.6. Voice by Quen3, TTS. Not affiliated with Hacker News or Y Combinator. Now go build something with whatever you've got lying around. We'll see you back here tomorrow.